This is Algebra 2, Lesson 1.4, Loans and Investments. So in this lesson, we're going to keep working with our shifted geometric sequences, but we're going to do that specifically with financial situations, like a loan, which is kind of where you have to borrow money and then pay it back. When you are repaying, you are expecting your balance to decrease, or an investment, which is where you are saving money. And in that case, you would expect your balance to increase. You're earning money, okay? So they both look pretty much the same for our recursive rules. You'd have your un equals un minus 1 like we always do. And then in our parentheses, I'm going to write this 1 plus the percentage divided by n. And this is compounding. I'll talk about that in a second. But this 1 plus the percentage is the same as like 100% plus whatever percent, but we're going to do it in decimal form. And then because we are repaying this loan, paying it back, our balance will be decreasing. So we're going to have a minus whatever our payment amount is. An investment looks almost exactly the same. We have our un equals un minus 1. And then we have add interest. We have compound that interest. But because we're trying to increase our balance, we're trying to save more and more and more, we're going to be adding our common difference. So the only difference between these two formulas is you repay your loan, you have a minus sign on your payment because it goes down and down and down and down, versus you have a plus on your common difference because you are depositing more and more and more and your balance is increasing. Now, compounding. Compounding is going to have different numbers depending on how often the interest gets added to the account. You can add interest once a year. Then your n would be 1. You can add interest once a month. Then your n would be 12. You could add interest once a week. Then your n would be 52. You could add interest every day. Then your n would be 365. There's lots of different values. However many it happens in a year. Like you could say semi-annually, n would be 2 twice a year. I'm going to just go with those. Those are the common ones that you're going to see. But it could be any period of time that you could break a year up into. How many of those per year, that's your n. Now, principal is just a fancy word for starting amount. We've already been doing this. We just never called it principal. Principal is just your starting balance. So usually that is going to be your U0. Let's try some examples. Example A, you plan to borrow $22,000 from a bank to purchase a new car. The bank charges interest at an annual rate of 5.9% compounded monthly. Assume you make a $500 payment each month. Write a recursive formula to represent the situation. Okay, so I know my U0, my starting number, my principal balance. I know my payment amount, my common difference. And I know my percentage rate, which I will have to convert to a decimal, but I'm going to put all this into my formula. So my starting value is $22,000. To get my next month's balance, I need to take my last month's balance and add some interest to it, specifically 5.9% interest. 5.9% as a decimal is 0.059, and we are compounding monthly, so n is going to be 12 because there are 12 months in a year. Finally, I'm making a payment on my loan, so I need to subtract $500, and that will tell me my next month's balance. Okay, that's plugging all those numbers into my formula. I'm going to go to the calculator. How much do you still owe on the loan after 1 year? Starting value times, and the nice thing about these calculators is you can type it exactly like you see it. You don't need to use your order of operations to calculate a number. We can keep all the pieces so we can clearly see we're adding 5.9% interest, we're compounding monthly, and we're also paying $500 each month. So after 1 month, that is my balance. Now be mindful, the question didn't say what's the balance after 1 month. It said what's the balance after 1 year. So I don't want to hit enter one time. I actually want to hit enter 12 times because there are 12 months in 1 year. So U1, U2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. U12 is $17,168.74. After 1 year, my balance went from $22,000 to $17,000. So I'm going to write this. U12 equals 17,168. And we'll keep 2 decimals because money, 74 cents. And let's throw a $sign for our label. How many months will it take to pay off the loan? Okay, so pay off the loan means we want the balance to be 0. So we're going to count how many more enters until we get to 0. And we probably won't see exactly 0, but we're going to go to our first negative value because it's the first one past 0. So that was 12 months, aka 1 year, 12. 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I'm at 2 years of payments right now. 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Been paying for 3 years. 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, and we are negative. So it took 50 months of payments to pay back this loan. I'm going to write U50 equals negative 148. But that means the answer to my question is 50 months. Ooh, I can spell months, I promise. So obviously that last payment, right? We were paying 500, 500, 500. That last payment was 300-ish, like 350, right? So that's why it shows we overpaid a little bit, but that last payment, you wouldn't make $500. You would pay whatever the balance is. Let's try another one. Example B, you plan to buy a house. You have been approved for a 30-year mortgage of $190,000 with a monthly payment of $1,296 and an annual interest rate of 7.25%. Funny story, this is exactly the mortgage I got on my first home. We bought a home for $190,000. That was our payment amount, that was our interest rate, and it was a 30-year mortgage. So let's figure out what I had to do way back when I became a first-time home buyer. Write a recursive formula. We need our U0. Our starting balance is $190,000. We have our next month's is our last month's with some interest. We have a 7.25% rate. So that is 0.0725 monthly payments. And we are paying $1,296. Bam. So that is our formula. I'm actually not even going to bother putting this into the calculator because I think you've seen me do that a bunch of times. Hopefully we know how to type these in. Instead, I want to talk about what the total cost of this loan is. So calculate how much you actually pay for the house. That means I'm going to be making this payment every single month for 30 years. So if I pay $1,296 every month for 30 years, that's going to tell me how much my $190,000 mortgage actually cost me. You guys ready for this? 1,296 times 12 payments a year times 30 years of payments, $466,560. So how come my 200,000, I'm just how come my almost, barely, not even $200,000 house costs me more than double with interest? That's how banks make money. This 7% adds up to more than double what I originally paid them. Now, luckily, this is not real life for me because we moved, got a new mortgage with a lower interest rate well before I gave a bank a free $250,000. But that's why you want to shop around, get your best rate, maybe pay more than the minimum so you can pay it back faster, not make so many payments. Anyway, one more example. Gwen's employer offers an investment plan that puts a portion of her paycheck before taxes into a savings account. She gets paid every week, and the plan has an annual interest rate of 4.75% compounded weekly. She plans to just put in $10 a week. Okay? So we're going to write the formula. U0. U0. How much money do we start with? Well, this is a brand new account. Brand new accounts are empty. We're starting with nothing. And then we're going to add some interest to that. So remember, we're compounding weekly. So next week, we're going to add 0.0475 over 52 because there are 52 weeks in a year. And we're also going to contribute $10. So I am going to type this one in the calculator. We start with nothing. And then we are going to add some interest. What am I, 475? But we are going to compound that weekly. And then we're going to add $10 each week. So after 1 week, I just have the $10 that I put in. That makes sense. But after 2 weeks, I have 20 because I put in another 10. And technically, I have 1 cent of interest because that 0.009 is going to round to 1 cent. So I have $20 and 1 cent. 1 cent, big deal, right? 3 weeks, 4 weeks, 5, 6, 7, 8, 9, 10. 10 weeks. I now have 41 cents of interest. So it's not a lot, but it adds up. And that's the beauty of compounding. Your interest earns interest. So the more you put in, the more you save, and you're getting free money just for letting your money hang out. So I stopped at 10. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52. I hope I didn't miscount. I think I counted right, but 52 enters seems like a lot of enters, especially when the question says find the balance after 5 years. But remember, every enter is a week. There are 52 weeks in a year. So I had to go to 52 just to get to 1 year. So the balance at 1 year is $532.30. We're going to round that, which means after I put in $520, right, I have earned $12.30 in interest. So again, it doesn't seem like a lot, but it's free money just for letting your money sit there. Plus it helps you reach a goal if you might have one. I'm not going to keep hitting enter. If this is asking me to go to 5 years, there's 52 weeks in a year times 5 years. I would have to hit enter 260 times to get to this answer. If you want to, go for it. I'll give you a little bonus unit. But I will never ask you to go this high on a test or an assignment. That's hitting enter a bunch. We got better things to do. But if you want to figure it out, go for it. Otherwise, I think that's it for these notes. Please let me know if you have questions. Otherwise, good luck on the exercises.